answering a couple of staff questions. All right, well, let's get going here, folks. Welcome to another edition of College of Science Virtual Seminar. As usual, I'm your host, Michael Kaufman, Dean of the College, and I'm really excited today to have a longstanding member of our campus and Moss Landing, and even a student here way back when, Dr. Jim Harvey. Just to give you a little background on Jim, Jim received his Bachelor of Science in, was it biology, Jim?
Yes. Yeah,
biology right here at San Jose State University. And following that, he went down to Moss Landing where he got his master's in marine science. And then from there went on to get his PhD at the University of Oregon, Oregon State. I can't believe I did that. My kid is at Oregon State. I should be really careful with these things. He joined the faculty of Moss Landing in 1989 and was a faculty member from 89 until 2011, at which point he took on the managerial responsibility of being the director of Moss Landing. And for those of you who don't know Moss Landing in a lot of detail, it's hundreds of people and lots of students and lots of faculty and research facilities, and the ever-present salt air beating on all of it in a relatively isolated location far from main campus. And in a very real way, being the director of Moss Landing is like running a small university all on your own. So it's a really challenging job, and Jim was fantastic at it. His scientific interests center around vertebrate ecology, and he has studied the foraging ecology, population dynamics, and health of sea turtles, birds, and marine mammals. He served as the major advisor at Moss Landing for 89 Moss Landing master's students and has more than 130 professional publications. He also currently serves on a number of state and federal advisory committees where he shares his expertise. Today, he's going to tell us about one of his favorite subjects, California gray whales and their life in the North Pacific. As usual, when we have these talks, feel free to drop a question in the chat or the Q&A. I'll be monitoring those throughout the talk. And if you ask something that looks like I should interrupt Jim on the fly, I'll do that. If not, I'll hold the questions until the end of the talk and you can ask him yourself. So without further ado, Jim, tell us about 1.5 million pounds of gray whales.
Thanks, Michael. Just a preface about this talk. Most of the work I'm going to be talking about is work I did in the past. I spent quite a bit of my time in San Ignacio Lagoon in Baja California. Probably a total of maybe a year of my life has been spent there. I did work on gray whales along the coastline of Oregon, California, and Washington, and Alaska. This talk is not so much a science talk with hypotheses and stats associated with it. It's more a natural history talk, trying to blend all the things I did with gray whales and some of the other work that a lot of other people have done, including some of my graduate students. So a little bit about what makes a gray whale. Gray whales are born at about 15 feet of size, 1,500 pounds or so. Maximum size is about 49 feet. The females get larger than the males, and that's a picture of a female on the far right side coming right up to my boat, so that I'm about 4 feet from the nose of that whale as it's coming up to our vessel in San Ignacio Lagoon. So they're medium-sized baleen whales. They're characterized also by having sort of a gray modeling, hence their name, gray whales. The white spots you'll see are oftentimes mostly scars from where barnacles used to be, but also be other scars from just scratching against other animals. And here's a picture of the head of a gray whale. You can see the two blowholes on the top of the head. They also are distinctive in not having a dorsal fin. They have knobby projections on the back of the caudal peduncle. So in this picture, the flukes would be off to the left-hand side. So they don't have a dorsal fin, which is pretty unique for a lot of the baleen whales. They also have throat grooves, and their numbers are 2 to 5 throat grooves, which is different than like blue whales and minke whales, which might have 100 throat grooves, and those throat grooves basically allow the throat to expand when the animals are engulfing water and their prey. They also have the distinctive curved arching jaw. The jaw actually, the top jaw extends a little farther than the lower jaw, which makes it unique for large whales. And this actually is a picture of a gray whale calf that was brought into captivity at SeaWorld down in San Diego, and I did some work with that animal before it was released. They also, as all baleen whales have, instead of having teeth, they have baleen, which is made out of keratin, the same material your sort of yellowish baleen with about 130 to 180 platelets on each side of the mouth. And this is just looking at the right side of a gray whale mouth to show you that baleen. And I'll talk a little bit more about that as we talk about foraging. They also have characteristically a lot of evidence of barnacles. So this is a picture of the barnacles on a gray whale's skin. These barnacles are only found on gray whales. They're not found in the intertidal or anywhere else. So this species is specific to growing on gray whales. And gray whales also have whale lice, which are amphipods that crawl around on the skin and eat the dead skin. Most cetaceans' skin turns over about every 7 to 10 days. So it's constantly sloughing off skin, and the whale lice are eating that skin, dead skin.
Hey, Jim, what's the size scale on the lice? Are they similar to land lice?
Yeah, the biggest one there on that picture is probably about 3/4 of an inch long. Okay, so let's talk a little bit about the evolution of these animals. So the upper left-hand cladogram basically shows you the history of how we get to cetaceans. The most closely related animals that we have now are hippopotamus and artiodactyls, artiodactyls being even-toed ungulates. Deer, cows, sheep, hippos, giraffe are all in the artiodactyls. And so cetaceans, the whales, come off of that group. On the right-hand side is a little bit more pictorial view of that what's going on here. So the hippopotamus still exists till to today. The early cetaceans were obviously land-based animals that then started evolving into animals that could use the aquatic environment, mostly freshwater initially. So Pakicetus, this animal I'm pointing to right now, is an animal that was a terrestrial animal, but was starting to get into the water a bit and evolving some characteristics associated with that. And the key characteristic that we're going to show you is as they evolve is the location of the nostrils. So on this Pakicetus, the nostrils are located right here, not quite at the tip of the snout, but up on the top and near the front. And as the animals evolve, that you'll notice that those nostrils will start evolving to be closer to the top of the head. Ambulocetus was the next animal that came sort of in the evolutionary chain. These are animals that are about 45, 50 million years ago. A skeleton of Ambulocetus is here. They started losing the length in their foreflippers, and they had paddle-shaped hind flippers to swim in the water. These are animals that are now starting to get into brackish water at this point. And further down the evolutionary chain, Ratocetus is an individual shown here. Same thing, look like Ambulocetus, but a lot more into the saltwater realm at this point. And you'll notice now that the nostrils are now a little further back on the skull. And then Dorariodon is a good example of an animal that's almost completely now saltwater adapted. Small front flippers. The hind legs are now completely gone and they're vestigial. And you'll notice that the nostrils now are about halfway down or back on the skull. And then finally we get to the evolution of the true cetaceans that we have today. Those animals were probably evolving about 35 million years ago, and we get a differentiation between the toothed whales, which are the odontocetes located here. Again, now you'll see that the nostrils are right up here at the very top of the head. So all the cetaceans now have evolved to have the nostrils at the top of the head, which allows them to swim along and breathe without having to put their snout out of the water. So the two groups, as I said, one are the toothed whales, which are the dolphins, porpoises, sperm whales are all odontocetes, and then the mysticetes, which are the baleen whales. Within the baleen whales, the evolution of gray whales are depicted in this cladogram. We believe gray whales fossils go back about 2.5 million years ago. The oldest mysticetes are probably the right whales and bowhead whales, and then gray whales are the next that come off. So gray whales are pretty old or ancient compared to many of the other baleen whales, like blue whales and finback whales and humpback whales that evolved later on. So that's the history of how we get to cetaceans. And we know cetaceans are related to artiodactyls, the cows and those sort of things, because we have a picture of that entity, and here it is. So there you go. Whales are very much like cows, and there's a breaching cow to just prove that they're similar to each other. So let's talk a little bit about the former distribution. These gray whales occurred in both the North Pacific and the North Atlantic until about the 17th century in the Atlantic. There are fossil records of gray whales on the northeastern Atlantic and on the Western Atlantic. And there's actual gray whales that were present in the Atlantic until about the 17th century, when whaling basically did them in. And so nowadays we only have gray whales pretty much occupying the North Pacific. And this is what their distribution looks like. There are two stocks that are currently recognized. One, the Western stock, which occurs, these are animals that forage in the north up off Russia, Kamchatka, that region, and then migrate down to off Japan, Korea, and China, which is where they breed during the wintertime. That population is really small, less than 300 individuals in that stock, and they're considered endangered under the Endangered Species Act. Whereas the eastern stock, the one I'm going to talk about mostly, is the one that forages up off Alaska region and then migrates along the coastline down to Baja California, to where they breed. And that stock is currently estimated to be about 27,000 individuals. It got delisted from being endangered in 1994. So that's a kind of a success story for this species. Good conservation efforts have led to this population rebounding pretty dramatically. And I'll show you pictures of that, or an image of that a little later on. The cool thing that's happened most recently is because, well, not so cool, I guess. It's mostly warming that's done it, that we've got a lot less ice up in the Arctic at this point. And because of that, gray whales now are leaving the North Pacific and crossing across the Arctic and coming down into the Atlantic again. So we had a gray whale sighting in the Mediterranean in 2010. And then in 2013, another gray whale was sighted off of Southwest Africa. So with global climate change and changing ice patterns up in the Arctic, we're starting to see a repopulation of the gray whales now into the Atlantic, and probably sometime in the future, they'll probably most likely be a population that will get started in that area. So let's talk about what they do in the north when they're foraging. So a little bit of discussion about foraging of gray whales. Gray whales are, at this time, are mostly bottom feeders. They generally will go to the bottom, turn on their side, as depicted in this picture, and then they suck up sediments, and in those sediments are amphiliscid amphipods, which is what the primary prey for gray whales in the off Alaska tends to be. And the next picture is a video here of a young male gray whale foraging, and you'll see him pumping sediments into his mouth. Now you can see it coming out the left side of his jaw as he's tipped on his right side, pumping sediments into the mouth, using the baleen to sieve out the amphipods, and the water and the mud come out the side of the mouth, allowing them to continue to forage. And here's a couple pictures of animals foraging on the benthic environment, and some depictions of what those amphipod beds look like. Amphiliscid amphipods come in really dense beds, which is what the gray whales are really going for when they're foraging up in Alaska. And the estimates are that these animals are eating about 67 tons of food in the 5 to 6 months that they're foraging up in the Arctic, sieving about 100 acres of sediment during that time frame. So huge disturbances to the bottom by gray whales, and of course, a necessity to have that kind of productivity to be able to support the 27,000 gray whales that are foraging in that region. So after they've spent their summer, now remember this is summertime up in the Alaska region, they'd go through a very lengthy migration, and I'll show you some evidence of even greater migrations than we thought before. But the typical animals going on through about a 12 to 13,000 mile trip down along the coastline, and then to the lagoons in Baja California, and then eventually we'll come back again and we'll talk through that through. So the title of my talk sort of depicts what I did was basically I did a back of the envelope calculation using the number of gray whales that we know are in the population times the average size of a whale to get sort of the poundage of gray whales that are going by our coastline. So these guys are migrating south past California during the winter to get down to the lagoons in Baja California, and then turning around and coming back in the spring, late winter, heading back up to Alaska. So they're going by our doorways twice a year. So that it's an amazing migration of a large amount of biomass going by us. And you might ask the question, so why migrate? If the food is so plentiful up there, what's the purpose of spending all that energy to travel so far to during the year? And the answer comes from partially from this image. This is net primary productivity in the marine waters of the world. And you'll notice that there's large amounts of productivity up in the North Pacific. So Bering Sea, which is where the gray whales are foraging, is one of the most productive marine environments in the world. And so the gray whales are taking advantage of that high amount of productivity to be able to sustain those benthic environments which they feed in. And then as ice forms and the water temperature cools in the Arctic, the animals have come to evolve a process by leaving those colder ice-covered waters and moving southward. And they eventually, obviously, at some point found the lagoons of Baja California to be a really great place to have their young. It's warmer water, less predators in those lagoons, which allows the gray whales calves to not only not be eaten, but also to grow very rapidly in those warmer waters before they start the migration northward. So here's a little map of that migration again. So here's on the eastern population. Most of the feeding areas are up here in the Chukchi Sea and the Bering Sea. They go through the Cape Sarachev right here. Migrate all most of the reproduction is occurring, and then, as I said, they'll migrate back. On the western zone, the Sea of Okhotsk is a hot spot for foraging along also the outer side of the Kamchatka Peninsula of Russia. And then these animals migrate southward into the Sea of Japan and off China for their reproductive period. So two different stocks doing two different things. And that's what we believed were separating these two stocks for many, many years until just recently. Well, let me say this first. So there's a progression to how this occurs. The animals are going southward, going through Cape Sarachev in November, December, coming down the coastline, and are off the California coastline heading south in December and February, with the pregnant females being the first individuals going by, and the last individuals being adult males and immature males heading south. Then after they've gone through the breeding period for a couple months in the south, then they start heading north. So again, we start seeing northbound gray whales off of our California coastline in February and May, up along the coastline again, all the way through Cape Sarachev in April and between April and July. And then they're feeding up during the summertime up in the Bering Chukchi Sea. With the northbound whales primarily being the first ones going through are the newly pregnant females, and the last ones coming through in May or so being the females with calves. It's a long migration, and there's some changes that have happened. One of them being, as I'll talk about a little later, the animals seem to be coming close to carrying capacity in the foraging areas right now. So the animals are starting to now stop, and not some part of the population is no longer making the full migration, but are stopping at different various locations along the coastline to feed on other things besides benthic amphipods, things as like mysids, cumatians, and other amphipods. These animals, mostly during the migration, are migrating about 100 in the 100-meter contour, so relatively close to the coastline, and migrating at a speed of about 1 to 5 kilometers per hour as they're moving. And that's based upon some data I'll show you in a second here with animals being tagged. And as I said, we believe that there were sort of these two different groups until just recently, relatively recently. Bruce Mate, my former advisor at Oregon State, put tags on 3 different individuals in Sakhalin Islands, Russia, up here in the up north left. And I'm just going to show you one track of the one that did the longest migration. This is an animal that left this area in November, came across like this to the south of Kamchatka, up across the Pacific, below the Aleutian chain, straight across, which is very unusual for gray whales, and then came all the way down to Baja and went to all 3 of the lagoons in Baja California where animals mate. Ojo de Libre, which Scammons Lagoon, which is this one here, San Ignacio Lagoon, which is this one here, which is where I did all my work, and then Magdalena Bay, which is to the south. So that animal from the Western Pacific, from Russia, migrated all the way across down to Baja, and then came back up the coastline, cut up like this, went around the Aleutian chain through Cape Sarachev, like a lot of the eastern population does, and then cut across and back to Sakhalin Island, and arrived there the following year, May 2012. So amazing migration by an individual, showing you now that the Western population of gray whales actually interacts with the Eastern population of gray whales. Recently, Jorge Orban has done some work that showed that of 43 animals that were photographed in Russia, 43 of all the whales that were photographed in Russia, 43 of them, 14% of the whales off Russia, have been seen in the Baja lagoons. So there's a fair amount of interchange between the Western stock and the Eastern stock, and that's something that we've just come to realize recently. During the migration, the animals go through a sort of a typical pattern of breathing 3 to 7 times at the surface. They'll come up, take a breath, go down a little bit of depth, come back up, and do that 3 to 7 times until they go on a longer dive, which allows them to get themselves deep enough so that they're the dynamics of swimming are much better. So the water dynamics are much better at depth. So the animals can save energy by actually going deeper in the water column, because they get away from the surface effects if they stay too close to the surface. And again, as I said, they're traveling about 1 to 5 kilometers per hour, and that's day and night. So there's a little bit of sleeping that's done on the migration, but most of the time the animals are migrating throughout that time frame. And this graph I threw in just to sort of let you know, if you were interested in seeing gray whales, one of the best places to see gray whales along the whole entire coastline is in Monterey Bay. The gray whales, as they're heading south, actually come across and go straight across the mouth, across the over the submarine canyon. And the Monterey Canyon is one of the deepest, or is the deepest section of their migration. So that's the deepest water that gray whales ever encounter in their migration, is in Monterey Bay as they go across the Monterey Canyon. And killer whales are now taking advantage of that situation by attacking gray whales, mostly on the northward migration when the females have their calves, but they'll also attack other animals. So there's quite a few kills of gray whales by killer whales in Monterey Bay region, and it's because of the exposure the animals have of crossing that Monterey Canyon and not being so close to the coastline, which gives them a little bit of protection by being close to all the waves and the sound that's made by the coastal waters. Okay, so once those animals have reached Baja California, they go through reproduction. I always like showing this picture. I have no idea what the artist thought how gray whales mate. They don't do it like this, that's for sure, but it's a fun picture to show anyway. This graph is just depicting sort of the life history of a calf. So on the x-axis is the length of the fetus or the calf in meters, and the y-axis is time. Animals start mating, or the peak of mating is typically on the southward migration, centered around about the 5th of December. So wintertime is sort of the beginning of the calf's or the fetus's growth. The fetus grows for about a year period of time, where it finally reaches about 5 meters or about 15 feet when it is born. Normally that occurs either right at the very south part of the migration or in the lagoons themselves. So the female now is having that calf very close to the Baja Peninsula and the lagoons when she finally has the calf. And then she is nursing that calf for about half a year to a little bit more than half a year, using milk that's about 53% fat. And just as comparison, humans' milk is about 3%, 4% fat. So the huge amount of energy being pumped into these animals to get them to grow that rapidly, from about a 5-meter animal when they're born to about a 8 to 8.5 meter animal when they're weaned. The weaning usually occurs on the northward migration, as the female is probably in the area of British Columbia, northern Washington. That area is when the weaning occurs, and then the calf is on its own. Mom gets jokingly a rest for about 3 or 4 months or so, and then potentially could become pregnant again the next year. So it's a 2-year process, a calf potentially being born every 2 years for an individual female. As I said, the lagoons of Baja California, where this is all occurring, are the primary spots for them. Scammons Lagoon, also called Ojo de Libre, is this lagoon. San Ignacio Lagoon, which is the lagoon, as I said, that I spent most of my time in, is right here. And Magdalena Bay in the south portion of the western part of the Baja Peninsula. This is an aerial photograph of the mouth of San Ignacio Lagoon. This little spit right here is where we camped out for most of the time that I was in Baja, in this lagoon. So I spent 3 months sleeping in a little tent in that little spot on 1 year. And the reason why we went down there to Baja was to do some work on trying to develop a new tag. Bruce Mate, my former advisor, has made his reputation basically on developing with me helping developing tags for large whales and then using them. And he spent the rest of his career after this putting tags on humpback whales, blue whales, fin whales all around the world. And he's the one that tagged those gray whales in Russia that came down all on the eastern side. So here's a picture of a gray whale in San Ignacio Lagoon. Here's one of our boats, a female here, and you can barely see a gray whale right here. This is a calf right up next to our boat. And because whales have a proclivity in San Ignacio Lagoon to come up really close to boats, it gave us an access to animals so close and quite a few of them that it really allowed us to have a good opportunity to try out different tagging techniques to be able to put tags and test different tags on gray whales to make sure that they would work. So here's just some images from San Ignacio Lagoon, a spy hopping whale, head of a whale, a breaching whale, and this is a male penis of a whale. The animals, because there's a high concentration of whales in very specific locations in these 3 lagoons, gray whales, like a number of other cetaceans, have evolved a method of competing with each other by sperm competition. So because they're all located in the same location, there's not an ability to have harems or territories or that sort of thing. So the animals, basically males, compete with each other by trying to over-compete in providing sperm. So they have these really large testicles, and the males have access to lots of different females. And the way that you are able to outcompete your other males is to produce more sperm than they are doing it, and therefore hopefully impregnate more females than other males. So as I said, after that all occurs, there's a calf that's born. This is a picture of about a calf that's probably about a week and a half old. These little white dots, not the big white dots, but the little teeny kind of cream colored dots around this are all barnacles. Those are all newly settled barnacles. And there's a whole life history about the barnacles that's kind of cool, that's consistent with what's going on with gray whales. So the barnacles spawn in the lagoon and disperse their young into the water column, and then those little teeny barnacles attach to gray whales because they're in a confined space in these lagoons. It allows the chance of encountering a whale are really high. That allows the barnacles to attach, and then the barnacles start growing and to the north and back to the south, and the movement of the whale through the water basically allows the barnacles to forage as they make their migration north and south. So the barnacles' natural history is very well tuned to what the gray whale's natural history is tuned to. These guys are suckling, as I said, a fairly high quality milk throughout their period of time with a female, gaining about 100 pounds per day and drinking about 50 gallons of milk per day. And as I said, we used that to our advantage, that these whales were what they call curious, or at least came up close to boats to allow us to start testing different tags. This is a picture of a gray whale right next to one of our boats with the mouth open, the upper jaw here, the lower jaw here, the baleen on either side of the mouth. And for those of you that know Moss Landing Marine Labs and some of the people here, this is Rick Starr on the upper left here. Rick was a Oregon Department of Fish and Wildlife employee at the time, a good friend of mine when I was at Oregon State. And so I invited him to come down and help us tag whales. So Rick was part of one of the years where we tagged whales in Baja, California. Here's a picture of one of the gray whales with one of our tags on it. For 1 year, we put these orange streamers on them to be able to identify the tag from a distance so we could see what the tag looked like. And then I'll tell you one story about one individual, just because it's got a nice little, I think, ending to it. So this is an animal we tagged in San Ignacio Lagoon on the 27th of February, 1979. Bruce Mate was a pilot, and he would fly the coastline from Baja, California, all the way up to our houses in Newport, Oregon. And he'd do that about every 3 to 4 weeks after we started putting tags on. So he would fly up and down this coastline every 3 to 4 weeks to see where our tagged animals were. This is older technology than we have today. Nowadays, our tags are satellite linked so that you don't have to go and listen for the tags. The tags are talking basically to a satellite, and the satellite is now letting you know where that tag is. In the old days, these days, the tag had to be determined where the location was by using a antenna and a receiver that you had to be within, if you were on a ship, maybe 3 miles from the tag, you could hear it. If you were in the air, like Bruce was flying, you'd be able to hear the tag maybe 5 to 6 miles away. But basically, you had to be relatively close to the whale to be able to determine where the tag was. So as I said, Bruce was flying up and down the coastline trying to determine where our whales were. He found this one animal that we tagged in February off of San Diego in 9th of April, then off of Coos Bay, Newport, and Tillamook Bay, 1, 2nd, and 3rd of May. And the story that's kind of interesting is that maybe as we saw this animal migrating, we came to the conclusion that it might be possible to hear the animal as it went through Cape Sarajeff, Unimac Pass, which is, as I said, is right here at the base of the Aleutian chain. Almost all the whales that come along this migration go through this small channel between islands there. And so it just happens there's a Coast Guard station that exists there. And we decided that we would try to send a receiver and an antenna to that Coast Guard station to hopefully see if those guys could hear this animal as the animal traveled by their Coast Guard station at Cape Sarachev. So I sent the receiver off with a long, tried to be succinct message to them saying, this is how you set it up. Here's how the antenna gets built and all these kind of things, because they had no knowledge of how the telemetry system works. So I send this package up to them, and after about a month and a half, I get a call from the Coast Guard station saying, hey, we'd like to send you your stuff back. And I said, well, why are you sending it back? And they said, because your whale went by yesterday. And I said, how do you know? And I said, well, we heard it. We heard what you described, this beeping sound. And so he actually had recorded it. So he played over the phone to me the recording of the antenna, or the transmitter signal, which is goes like this: beep, beep, beep. So it was the same frequency, the right periodicity, everything that for that whale. So it was for sure the whale that went by. And he said, yeah, it went by yesterday. And I said, well, by the way, when did you get the receiver and antenna? And he said, we got it the day before the whale went by. So basically, and I had sent the receiver and antenna a month and a half ahead of time up there. And the package arrived the day before. They set it up, and the day after the package arrived, they heard the whale go by. And they thought that I had planned that all out, that I was planning on having them receive it just the day before they received it, or the whale went by. But the reality is, it took that long for the package to arrive up at Cape Sarachev. So it's a good indication that science works very well if you're well prepared and everything else. And every once in a while, you have to be really lucky. And that was just one of those cases where I was just amazed that we were able to get something there just in time for the whale to go by. And so I'll finish up this by talking a little bit about exploitation and climate change, to talk about some of the things that have happened to gray whales over their history. There's been 3 phases of exploitation for gray whales. The original people lived along the coastline, harvested gray whales a little bit. There was shore-based whaling, and there was pelagic whaling, and I'll describe those in a little bit here. And then currently, the threats to gray whales involve entanglements in the variety of gear. They also are susceptible to being struck by ships. And then climate change is the big one. And they're a very good example of how climate change is affecting gray whales. And this is a picture of one of my grad students standing next to a male gray whale. So this graph just shows you the population levels of gray whales as they went in the early 1800s. They collapsed a little bit. Then the start of shore-based whaling occurred. The population went down till the point where it was not feasible to hunt them anymore, and they started coming back up again. And then pelagic whaling started, which drove the population down again dramatically. And eventually, because of the low numbers, the International Whaling Commission protected them. Their population started increasing dramatically after they were protected. They got up to about 18,000 individuals before there was some issues with prey reduction, and the population went down a little bit, and now currently has gone back up to about, as we talked about 27,000 individuals in the population. And most people right now consider the population to be very close to carrying capacity, given what we know about prey resources into Arctic. But that question about carrying capacity has been coming up recently, because some molecular work may indicate that there might have been 96,000 individuals in the population, Eastern population, 120,000 years ago, based upon molecular diversity indices. And therefore, we're now questioning whether the population really is at carrying capacity, or whether the population potentially could be much higher if the conditions continued this way. And a lot of it has to do with climate change. As you would expect, if the whales have been around for millions of years, they've gone through periods where there was very large ice-covered events, and then events where the ice was gone. We're obviously in a period where not only is the Arctic, well, are we in a non-ice period, but we're also in a place where we're, with climate change, really affecting the ice cover. So I'll talk about in a slide here soon here, some of the bottom line here is that the gray whales have gone through periods in the past where they've been subjected to ice ages and non-ice periods, and therefore have probably evolved all kinds of mechanisms to withstand periods where they have different types of environmental conditions associated with their where they're foraging. So there's been a variety of different ways that whales have been taken. In North America, Aboriginal whaling occurred for a long time, a lot of it off of British Columbia. And here's a picture of one of those individuals that was with the flippers of seals, but they took seals and then inflated their skins to create the buoys, and then used harpoons to harvest gray whales. Whenever I'm out tagging whales, I always picture this thing and put my face in this image here, just as I feel like sometimes we're kind of archaic on some of our things we do. But gray whales were obviously harvested during this time frame for a variety of things, including their blubber, meat, bones, and that went on for many, many years along the coastline before the advent of shore-based whaling, which some of the early shore-based whaling occurred in Monterey Bay, actually. This is a picture, rendition of basically of a whaling station at Point Lobos in Carmel Bay. The animals were taken offshore with small boats and then brought to the shoreline and then harvested on the coastline. And here's a gray whale being flensed by a number of individuals during that time frame. So this shore-based whaling occurred for probably about 50 years, from the 1850s to 1900s, early 1900s, and mostly by Portuguese immigrants who had come in and had been whaling in their past country. The first station, shore-based station, was in Monterey, California, with it now it was called the Monterey Whaling Company, which was started by John Davenport, who was a New England whaling captain, moved from the East Coast to the West Coast, and took whales, a number of different species of whales, off of Monterey Bay for a number of years, and eventually in 1868 moved to Davenport, named after him. So the town of Davenport is named after the whaling captain, John Davenport. And that shore-based whaling went for a number of years until they basically removed enough whales that it was no longer commercially valuable to keep whaling that way. So then, as I showed you on that graph, the numbers started going back up, and then pelagic whaling started, and they started going after animals with vessels and harvesting them at sea. And this is an example of some of the whale bones left over from whaling, from the whaling station at Moss Landing. This is, if you've ever been to our aquaculture center, this building that was part of the whaling station is just to the north of where our present Moss Landing Marine Labs Aquaculture Center is. So as I said, the primary spot for harvesting, or for foraging by gray whales, was up here in the Arctic. And this is a Google Earth image showing you this large shelf that's 200 to 300 meters depth here. So all of this water is relatively shallow, which gives it a large area that gray whales, which are benthic foragers, could feed on very effectively. And hence why this ended up being the current primary area where gray whales are foraging, because it's a huge area with lots of shallow water that allows gray whales to get to that depth to forage on amphipods. But because those populations have gotten large enough, they are starting to put a little bit of pressure on other animals. So quite a few whales now no longer make the full migration. And these dots indicate some of the locations where gray whales now are foraging during the summertime and not making the full migration up to the north, but foraging in these regions to the south. And they're going back to the same locations enough times that they are actually now called a special thing called the Pacific Coast Feeding Group. So these individuals are now distinctly a little bit different than the rest of the gray whales that forage to the north. And a lot of that has to do, again, with climate change issues and feeding capacity. And this is a depiction by Wayne Perryman in his work showing how the calf production changes throughout the year. So this is a survey year, and it turns out that on years where you've got a large amount of ice forming early, you get low calf production. And years where the feeding area available to you, so the feeding time available to you in days, because ice is coming in late, you get high calf production. So if you link that to what's going on with climate change issues, it all sort of makes sense. This is a graph showing you ice cover over the years, many years, going back hundreds of years, and you'll see that it's kind of fluctuated year to year, but still remained about the same. And then now it's dropping dramatically as the ice cover is being removed because of climate change. This is an image from ice cover in March of 1985. This is ice cover in March of 2021, and you'll see a dramatic reduction in ice cover, which would, how's that affect gray whales? Well, ice cover changes currents, it changes productivity. And so because there are more ice-free days available now, we would expect that gray whales will have more chance to do feeding. But the effects on productivity are that the pelagic prey are going to be the ones that win. The benthic prey are going to lose with this new regime with less ice cover. So although gray whales will have more days to feed, there will be less benthic prey that will be available to them, but more pelagic prey available to them. And because gray whales have a flexible diet and allow them to feed on a variety of things, we're not quite sure whether they're going to win or lose with climate change. But it's clear that the gray whales will continue to have a lot more access time-wise to the foraging up in the north, in the Arctic region, as there'll be more vessels and activity up there that might impact them. So with that, I think that's the end of my tale.
Thank you, Jim. That was cool. I got one for you, and you might have just answered it in your last slide, but I was really fascinated by the migration data you showed, where the whales are going all the way from Kamchatka all the way to the coast of British Columbia, I think, in a straight shot. And at least at a first glance, to me, that looks like that's avoiding their main feeding grounds. Is that accurate?
Yeah, so those are animals that are feeding off of Russia and then going to the breeding grounds on the eastern side instead of the western side. So they're not making the typical, the Western population typically would feed off of Kamchatka, Russia, and then head south and go and breed off of China.
Right.
That particular animal, went foraged in Russia, and then at the end of their foraging period in Russia, went straight across the Pacific and then came down to Baja. So they avoided, they didn't feed in the Arctic or the Bering Sea, Chukchi region, avoided that and just went to the breeding grounds down in Baja.
So the reason I asked that is that I did a little Google Maps, just kind of how far was that? And my first order estimate of it is it's something like 4,000 kilometers in a straight shot, which at the highest speed that you listed for them would take them more than a month to cross that distance. Does that sound about right?
Yes, that's about right.
So that's a pretty incredible amount of time to go away from your feeding grounds.
Yes. Well, and gray whales, just so you know, so gray whales are I maybe I mentioned this. So gray whales, like, let's use the eastern population. The animals foraging up in Alaska, foraging there till about October, November or so, and then make a migration down to Baja, arriving down in Baja in December, January, turn around and go back up. And many of those whales never feed on that entire trip.
Okay, so it's not outside the bounds of their normal behavior. It's
correct.
It's just a weird crossing.
Yes.
Yeah, exactly. I was just impressed with that distance away from the feeding grounds.
Yeah. No, they'll go for a good 9 months or so without, or 8 months without eating, and migrating that distance at the same time. So
That's
incredible. Yeah, and they'll lose between 20 to 30% of their body weight during that trip.
cool. I guess that's why you have to stock up in the feeding grounds.
Exactly. Yep. And that's why it's so important to, and why the populations have gone through bottlenecks in the past during those ice cover ages, where that whole northern Bering Chukchi Sea is covered with ice and the gray whales just don't have access to it. So they're restricted to the southern part of their range for foraging. And we are pretty sure that that has created a very regular bottlenecks in the population dynamics, because the population probably dropped from maybe 80, 90,000 to 10,000, 6,000 individuals or less. And then as the ice receded and that area became available to them again, the population started expanding again.
Cool, thanks. We got a question from Tiana Young. Tiana, you should be able to turn on your mic.
Hello.
Hey.
My question was, how are you able to tag gray whales if they don't have a dorsal fin?
Yeah, so I'll try to give you the short answer. It's a long answer, but I'll give you the short one. So there's the ones that we've been using. The ones I showed you have these little prongs that stick into the blubber layer of the gray whale. So it's like a toggle that goes into the whale and holds the tag on the surface. And those tags that I showed you require that you be relatively close to the whale. You got to be 8-10 feet away from the whale to be able to put them on. The other tags that Bruce has now developed are shot out of a shotgun kind of thing, affair, and or a crossbow. And those tags go in about maybe 6 or 7 inches into the animal, and the antenna is the only thing that sticks out. And in those cases, the tags are being placed on animals that might be 10 to 20 feet away from the boat, tagging boat. So the tags are being stuck into the blubber layer, which is a kind of an inert area that they store their energy in it. And there's very little innervation and less blood vessels associated with blubber. So it's a good place to put a tag. It doesn't, well, I say it doesn't hurt the animal. I'm sure it hurts it a little bit. It's like probably getting a prick in your skin when you get a needle stuck in you, but it's a really short-term impact to the animal. And then the tag sits there as a little sliver in the blubber until it kind of gets pushed back out.
Thanks. Let's see, Curtis Asplund. Let me turn on your mic. Go ahead, Curtis.
Hello, great talk. Thank you so much for telling us about these whales. And I wanted to ask you about an article I read in the LA Times from last year about like unusual die-offs and strandings, and yeah, just questions about what was happening. So yeah, if you wanted to speak to that generally, and I guess a little more specifically, I was wondering if you had an opinion about like, should Mexico or the US be creating more sanctuaries or other things like public policy wise to protect the whales?
Sure. Yeah. So yeah, there is right now currently what's called an unusual mortality event, a UME. I actually sit on the federal national UME panel. So it's a group of individual scientists and others that meet on a very regular basis to determine what kind of marine mammal unusual mortality events are occurring. And we're currently in one kind of at the end of stage of a current gray whale mortality event. So there's quite a few gray whales dying up and down along the coastline, all the way from Alaska, all the way down to Baja and back up again. So, and there's all kinds of reasons for the mortalities. Unfortunately, as you might expect, a lot of the whales die and we don't get to do the necropsy and examine them until they've been dead for a number of days. And therefore, it's really difficult to determine what the cause of death was when the animal's been dead for that long. But the ones that are relatively fresh that we've been able to get our hands on, those animals, the bulk of them have been dying from emaciation, from lack of food. There's other ship strikes and entanglements and other things that have also caused some of them to die, but a large portion of them are dying because of a lack of food. And again, it goes back to what we're starting to see with climate change, that the benthic environment in the Arctic is suffering from the changes that are occurring there. We're expecting that pelagic prey species will start going up in numbers, and the benthic environment is going to continue to go down. But in the meantime, gray whales are suffering because they haven't quite made the switch over yet to an environment in which the benthic environment is just not there as healthy as it used to be 3 years ago. The gray whales right now are protected by international law and by U.S. federal law. So there are the lagoons in Baja California are protected by the Mexican government, and gray whales are not harvested anywhere else but in Russia and a little bit up off of California and in Alaska. So there's a few Native Americans that are still taking gray whales, but very few of them. So we're not worried too much about the gray whale takes by whaling, but mostly by the impact that the environment's having, climate change is having on populations. So yeah, there's a typical or a unusual mortality event with gray whales that's occurring right at this time right now. And it'll probably continue until the whales the population has gone down enough to kind of stabilize, or the prey resources rebound a bit, and gray whales have access to more prey.
Okay, thank you.
Jim, can I follow up on that for 1 second?
Sure.
And just say, how do you count the mortality events? Like what percentage of the animals end up, washed up?
Yeah, that's a good question. So there's been quite a bit of work trying to figure that thing out, because we obviously know how many animals wash up on shore because they're big enough that everybody reports them. When you got a stinky dead whale in front of your house, you usually call somebody. So yeah, we get reports of the ones that have washed up, but we don't know the animals that either die and sink or are eaten offshore and just don't make it into the. And then we've done some estimates, and the estimates are about 30 to 40% of the animals that die make it or wash up on shore, and the rest of them are not seen. So based upon what the population levels are and estimates of, like, let's just use stranded animals that have died and washed up on shore, we know sort of yearly. There's a whole group of which Moss Landing Marine Laboratories and myself have been involved with for years, which is part of the National Marine Mammal Stranding Network. So for the last 40, 50 years, we have very good numbers on how many dead animals have washed up along the coastlines of all of the United States. So given those numbers, you kind of sort of know what normal is. And then when you get large numbers of animals, then we've got a statistical team that basically comes back and says, okay, this is abnormal. Then we decide whether we're going to make it an unusual mortality event. And what that does is trigger federal funds to allow them to investigate what the issue is.
Got it. Nice. Let's see. I don't see any other questions in the Q&A, and we are a few minutes past 5 p.m. So let's thank Jim one more time. Thanks a lot for a great talk.
Thank you. It was great.
Learned about marine lice, which was cool. And for those of you who are able, an invitation went around for a happy hour immediately following this. So if you can join us, please do. Thanks everyone for coming today. Thanks, Jim. That was a lot of fun.
Sure. Thanks. Yeah, it was fun. It's always fun to talk about gray whales and some of the things. Whenever I do it, it always reminds me of one of my best parts of my life has been my time spent in Baja California.
That must have been super cool.
Yeah. My joke about that is we'd get up every morning and we'd decide, okay, do we wear a t-shirt or not? If it was
Right.
if it was cool, we'd put a t-shirt on. If it was
Right.
warm, t-shirt stayed off.
Nice. Yeah, the skies must have been amazing down there with just out on that little spit of land.
Yeah, spectacular. And then the other fun thing was that because the whales are down there during the winter time, we would leave Newport, Oregon, which is pouring down rain
Mhm.
in the middle of the winter, go down there, and we return back on the long trips. We were down there for 3 months. We would turn back in the spring, tan and
Beautiful.
all kinds of, and everybody else has been, living in rain and overcast the whole time. So it was a great way to get paid to go do something very fun.
Nice. So if you're able, want to log on to Happy Hour for a little bit, you're more than welcome to do so. I sent out a thing a few minutes after the talk started. So
Okay.
I'm going to shut this down, and anyone who wants to join us on the other side, please do.
All right. I'll join you.
Thanks, everyone.
All right. Bye.
Bye.